For this lesson, you're going to need a graphing calculator, or if you open your computer tab and go to desmos.com, you should get to a screen that looks like this, and this is a built-in graphing calculator. So we can use either one. So if you want to open one of the two, when we get there, it'll be all set. Pause this video and get that open. Okay, so a dog trainer is fencing an enclosure represented by the shaded region in the diagram. The trainer will also have two square-shaped storage units on either side of the enclosure to store equipment and other materials. She can make the enclosure and storage unit as wide as she wants, but she cannot exceed 100 foot in total length. Okay, so that's the longest she can make the whole figure. Let S represent a side length in feet of one of the storage units. Label the length and width of the enclosure in terms of S. So a side length of the storage unit, this part here would be S, since these are squares. This would be S. At this end, the same thing, we have S and S. So if we want to label the enclosure, which is the shaded region, this side would be the same, S, and so would this side. But how long would this side of the shaded region be? So if we want to find this side of the shaded region, we would have to take the 100, which is the total length of the whole region from end to end, and subtract away the S from this end that goes from here to here, and the S at this end. So subtract away 2S. So that would be the label of this unit, so part A. B says write a function, LS, to represent the length of the enclosure as a function of the side length. So the length of the enclosure would be 100 minus 2S. So that is our function. Depending on the side length, it's going to change the length of the enclosure. So as S changes, it will change this length. Sketch and label a graph of the function on the given coordinate and identify key points. And it says, to identify key points, think about the function you are representing. Are there any intercepts? Are there any interesting points? So let's graph it first. To graph this, we're going to start with the graphing calculator. For those who have a graphing calculator, you're going to go y equals, and again, our function has L's and S's, but we're just going to treat them as X's and Y's. So y equals 100 minus 2x. And then we're going to graph that. And we should quickly see that it doesn't fit on our window, and that should make sense because we know we're working with hundreds. So we're going to change the window. And we're going to change the window. So the smallest S can be is 0 because we can't have negative S values. The largest S could be, if we think about this, is we have 100 minus 2 S's. The smallest, the biggest S could be would be 50, because after that we get negative lengths, and that wouldn't make any sense. So 50 is our max. And then we're going to go to the Y values. The smallest the Y value would be 0. We can't have negative length. And the largest the Y value would be 100 if we had 0 for S. And now we're going to graph that. And we should see a nice line coming down. It starts up at the 100, which was the max, and it goes out to, again, 50 that way. So if we sketch this on our graph, we would start, this would be 100 here, and we put 50 as the max out here. And we have a nice line coming down there, okay? And if we think about this, if we go on Desmos, so hold on, I'm going to flip my screen up to Desmos. If you don't have a graphing calculator, then using Desmos, you're going to type in right here, y equals 100. Oops, sorry, I got to get my key back. 100 minus 2x. And then if we hit graph, you're going to notice it doesn't fit on the screen. We once again, to adjust the screen here, we go to this tools button over here. And we're going to go down here for the x-axis. We want to start at 0 and go to 50. And for the y-axis, we want to start at, sorry, it's a little 0 and go to 100. And now we see the same picture. So you can graph on desmos.com if you don't have a graphing calculator. Okay, so now let's continue with the worksheet. I'll zoom back in a little bit. So it says sketch and label the graph of the key functions. Identify key points. So right here, this key point is the y-intercept. Okay, down here is the x-intercept. So these are some important points if we think about that. Okay, so then it says describe the domain and range. If you remember from domain and range, domain is the x values. The smallest we said x could be was 0, but it's really the s we're calling it here. And we really cannot get a side of 0 because that would make it so that we wouldn't have a rectangular enclosure. So s is going to be greater than 0 and less than 50, because if we get to 50, that would make it so there's no length and it wouldn't be a rectangle either. The range are the ls values, or the length, which again can get as small as 0 but not include 0, and that's ls, and then it can get up to 100. Okay, so the domain and range, you should remember talking about those before. What are the possible values? And then it asks us to identify the key characteristics. So the slope of this graph, if we look up at the equation, the slope is always a number in front of the x, so the slope is -2. What does that mean? That as the side length increases, as the side length increases by 1 foot, the length of the enclosure decreases by 2 feet. Okay, so it's -2. So it goes down 2. It's decreasing the enclosure every time the side length goes up by 1. The y-intercept we said earlier was 0, 100. Okay, and that's the max for the length of the enclosure. And again, we said it can't quite get there, but that's the max length of the enclosure. Increasing or decreasing, it is decreasing the whole time. And then the x-intercept is at 50, 0. And again, that's the smallest or the largest side length. But we know it can't get there. It can only approach there. Okay, so now let's take this a little further. We're trying to find the area of the enclosure. We haven't talked about the area of the enclosure yet. So for this, we're going to write the function of the area of the enclosure. But before we do that, we've got to kind of analyze what's going on here. So this is a diagram that shows us how the area changes depending on the side. So let's think about if the side was 1. Okay, and then the length would be 100 minus 2 times 1, because it's 2 times the side length, which would be 98. And 98 times 100 is 98 feet squared. So that's what the length was 1. What about if we say instead we want the length to be 2? So then we would do 100 minus 2 times 2, which is 96. And 96 times 2 is 192 feet squared. And then you're like, okay, well, what are you going to do next? What happens if the length is instead, and let's go up and not just count by, let's go to 4. So 100 minus 2 times 4 is 92 times 4, 368 feet squared. And then let's say, well, what about if it's 5? 100 minus 2 times 5 is 90. 90 times 5 is 450. And then let's kind of double that. We're just trying different numbers so we can see the pattern. 2 times 10 is 80. 80 times 100 is 800. We can see that this keeps increasing. Let's go to 20. And that's 100 minus 2 times 20. That would be 40, so that would be 60. 60 times 20 is 1200. Let's go to 40. And we do 100 minus 2 times 40. 100 minus 80 is 20. 20 times 40 is 800 feet squared. And then let's go to 50. Or actually, you can't go to 50 because we'd run out of room, so we're going to go to 45. 100 minus 2 times 45 is 90, would be 10. And this would give me 450 feet squared. And if you notice, looking at this pattern, all of a sudden we were going up and up in area, and then we hit a certain point and we're going down in area, and they say, oh, that's interesting. So what is the actual formula we've been using for each of these problems to figure this out? We found the length here, right? We found the length by using our formula 100 minus 2 times the width, the side length. And then to find the area, we took the length and we multiply it by the width. And if we figure that out and we write our formula here, A equals, what is the area, the function of the area? A, in terms of S, is the side length times 100 minus 2 times S. Okay, so if we took the 100 minus 2S, which is the length, and multiply it by the side length, we get the area of the enclosure. And the area of enclosure, how does it change as the side length increases? At the beginning, it's increasing to a certain amount. With our examples we were looking at, it increases to 20, and then it starts going back down, but we don't know the numbers in between. And then it begins decreasing again. So now it says, consider the graph of the function. Predict what the graph of the function would look like. So draw some kind of little sketch of something, as we know, it increases, then it begins decreasing. What do you think that visually is going to look like? All right, and now we're going to use technology to actually graph this. So if I was to graph this using technology, I'm going to start with the graphing calculator. All right, and we're going to get to our graphing calculator, and we're going to clear out the y equals and put in our new formula, which is, again, the x's are going to be, or s is going to be x, so x times 100 minus 2x. All right, and then we're going to graph, and we're probably going to say, oh no, where did my graph go? It's kind of not on the screen. So we have to think about this, because now we're working with the area, but it came back down. If we want to set the area, our width looks okay. We got 0 to 50, but our height is not there. So if we look back at our paper when we were doing this, we got all the way up to 1200. So if we go to our window, right now the max is 100, which is why it's off there. But we don't know if it went higher than 1200 or not, because we didn't get all the numbers in between. So let's put this to 2000 just to be safe, and then graph it. And now we see this figure forming. And this is your intro, first exposure to seeing a parabola formed. A parabola is this curved shape that is formed by any equation. That's what we call a quadratic equation. And a quadratic equation is any equation where it's second dimension. So area, 2 dimensions. Anytime we have that second dimension. In our formula, we have an S times an S. So we have an S squared, second dimension. Okay, so that's what we're going to see that parabola form. So now we got to figure out some values on this in order to graph this kind of on our paper. So we know the smallest point was 0 and the highest was 50. Okay, we're going to now figure out where the highest or the max point on this graph is. So we go second and calculate, and we're going to find number 4, the maximum value. And we're going to pick something to the left side and something to the right side. And hit enter one more time. And we're going to round this to 25. The maximum value is at 25, 1250. So we're going to go and split this in half. I think it was 20 boxes across. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is at 25. And then you can kind of stick a point on that line up here somewhere and just label it 1250 because that was the max. So it's going to curve up to the 1250 and back down to the 50. Okay, so that's our picture. If you're using Desmos, you go back into the equation here. We're going to exit this out. We're going to put in our y equals, what do we have? Oops, sorry. X times 100 minus 2x. And we're going to hit enter. And we're going to say, well, the graph didn't show up. We're going to adjust our table, so we're going to make our x-axis go to 2000 just like we did on the other one. And now you can see, if you read this graph, you can see that max point right here. If you click on it, it tells you the value. Okay, so if you're using the Desmos, that's how you would do that on there. Okay, so this says describe what all the points on the graph represent. So if you just think the points on the graph, any point on this curve tells you the x value is the side length and the y value is the area. Okay, so depending on the side length, it tells you the area. We're going to label this graph side length and area. Okay, so now we're going to turn the page. The function AS that you wrote in model area as a quadratic function, the shape is called a parabola, like I had mentioned a minute ago. Think about the possible areas of the enclosure. Is there a maximum area the closure can contain? And we know that that's yes, because when we looked at that graph, the maximum area was the highest point on the graph. So in terms of the graph and in terms of the context, so the answer is yes, the graph had a max value. And as terms of the context, we're going to say yes, because the side lengths are limited. Zero to 50, so it limits the area. So if you have limited side lengths, then you're gonna have limited area. Use technology to determine the max, which we just did on the previous page. The max was 25, 12, 50. Okay, describe the x and y coordinates of the max. So this is the x coordinate is a side length, and the y coordinate is the area. Okay, so a side length of 25 gives this person the maximum area for the dog enclosure. Determine the dimensions of the enclosure that will provide the max area. Oh, look, I just said that. It's 25 feet by 1250. Oops, sorry. We didn't figure out the length yet. So the length is 100 minus 2s. So the 25 feet is 25 feet. If we multiply this out, we get 50 feet. So sorry, that's the dimensions. Okay. And then it says identify the domain and range. So again, for the side length, it's anywhere from 0 to 50, not including those values. And the area is anywhere from 0 to 1250. And we can get to 1250, okay, because we know that was part of between the 0 and 50, the 25 is included, so the 1250 is a possibility. And then it says identify these characteristics. The y-intercept was at 0, 0. And what did that tell us? That told us that if we were at 0 for a side length, the area would also be 0. It's not actually possible. It's increasing from 0 to 25 and decreasing from 25 to 50. This is just a way to write the notation. So it increases from 0 to 25, decreases, or you can write this as 0. And we've learned about our intervals of increasing and decreasing. You can say it like this, between 0 and 25. Okay, and what does that mean? The increasing means the area is going up, and then decreasing is going back down. Symmetry is at x equals 25. If we look back at our graph, there is a line of symmetry right down the middle of the graph here. Okay. And then x-intercepts were at 0, 0, and 50, 0. And once again, those are the values in which the area would be 0. So that is our introduction to parabolas and how to find the area. Every area will graph as a parabola because it is squared. And if we find our graph, we can find the max area for any enclosure.